So the ants get the honeydew from the aphids, that's a good thing. The aphids get protection from the ants, that's a good thing. So here is your classic symbionts. They're helping each other. It's not, it's that they're really thinking about, oh, we'll help each other. But it turns out to be a win-win situation. Down on the right, there are butterfly caterpillars that also do this honeydew thing, and ants will get the honeydew and protect the caterpillars. Now off on the left, we've got crickets on the top called ant crickets, and there's a beetle below it. These are guys that live in ant nests, and they hang around the ant nests, and they trick the ants into feeding them. And so the ant crickets get fed by the ants. They're doing well to be living with the ants. As far as we know, they don't do anything to help the ants. So this, there are things that mutual helping each other, and then there are cases where one thing gets helped by the other but doesn't really turn anything back to it. But the ant crickets need the ants around to survive. So another topic about insect ecology is how do they reproduce, and they have to reproduce. If they're in an area and they're going to survive, they have to reproduce. They have to have methods of doing that. We talked about the insect life cycles, and most of them had an egg stage. So naturally, you think at some point the insect has to go out, lay its eggs, has to find a place to lay its eggs and do it sufficiently so that the eggs will hatch and the young can find food and grow up. This egg-laying strategy runs the whole gamut of things, from insects just going out. If you know walking sticks, we don't find much around here, they're more in the tropics. But walking sticks are insects, they live in the tropics in the forest, and when they lay their eggs, they just drop their eggs. Just walk in the tree, just drop their eggs onto the ground. That's their reproductive strategy. The babies find their way back up into the trees. They don't do anything. A lot of insects know what the host plant is, or the host adult is that their young have to feed on, and they go and they lay their eggs in the proper place. Here's some examples of it. Leaves with insect eggs on them. Because the adult seeks out the proper plant, lays its egg there. So giving the young a head start to survive. Up on the top right is a giant water bug. It glues its eggs to the back of the male water bug. Instead of just dropping the eggs on a plant or something, glues the eggs and the male carries them around so the eggs are protected until the eggs hatch. And then the eggs hatch and the little guys swim away and they're on their own after that. Naturally, strategies have evolved so that you've got things that just drop their eggs, things put their eggs in the proper place, things protect the eggs until they hatch. And there are some insects that provide for the young a little beyond that. Like down on the bottom right are earwigs. Earwigs lay their eggs in the ground on the rocks, and the female hangs around with the eggs until they hatch. And then the eggs hatch, and the little earwigs hang around under the rock, and the female takes care of them until they grow up to a certain stage. She protects them, and then they get to a certain size, and then they go off on their own. The wasp up in the top left, it is a solitary wasp, and what it does is it flies around and finds food for its young. Its young feed on things like crickets or spiders or grasshoppers. It'll go catch a spider or a grasshopper, dig a hole in the ground, paralyze the spider, stick it in the ground, lay an egg on it, and then cover it over. So when the egg hatches, the young wasp grub has its meal there, feed on and grow up on it. So that's some type of parental care to help increase the chances that its young will survive. And then naturally we go to the extremes where we have social insects like bees and wasps, where one queen lays all the eggs, and then her children that hatch out run the hive and take care of all the young that she produces. They feed the young, they house the young, they build the hives, they go out and collect food, bring it back, take care of the young. So this has gone from the walking sticks that just drop their eggs and go away, to the social insects that have these big communities that they build where the young are totally taken care of until they become adults and hatch out, and they're ready to continue helping survival in the hive. So how long do insects live is a question I often get. And being the entomologist that I am, my answer is, it depends. Depends on what insect you're talking about. There are all kinds of insects, and they have all kinds of life strategies, and all kinds of lengths of life, depending on what the species is. So we have things like aphids on the far left here. Those guys, they're living on the edge. They're churning out babies as fast as can be. They're going through their life cycle as fast as can be. How many generations do they have? A lot of aphids will have something like 3, 4, 5, 6, 7 generations a year. That's why you can look at your rose bush and one day there are no aphids there. Look at it a week later and there's dozens. You look at it a week later and there's hundreds, because their life cycle is so short, they go through so many cycles so quickly. See that aphid up in the top left there? They don't even lay eggs, a lot of them, or at least for most of their life. They pop live young out the back. So there's a mother there, and there's a baby aphid coming out the back. And some of them, the baby aphid has a baby aphid inside of it when it's coming out. It's already got a baby. They're that fast. So like I say, for aphids, many generations a year. Something like this sulfur butterfly in the center, they often have 2 or 3 generations a year. So you'll see the butterfly in the summer, it lays its eggs, caterpillar hatches, makes a pupa, another butterfly comes out, lays its egg, goes through another life cycle, fall comes along, and then the pupa stays as a pupa through the winter. Then the adults hatch out in the spring, and it'll go through several cycles each year. Most of them crammed in the summer with one life stage that spends the winter in hibernation in that one life stage. Something like the Japanese beetle there has 1 generation a year. It's just nice and simple, easy to visualize. Egg, larvae, pupae, adult, takes a year for the whole thing to go through. A lot of insects are that way. So a lot of times my answer would be, well, a lot of insects, they live about a year for their whole life cycle. Yet each stage may be anywhere from a few weeks to several months, but taken as a whole, the cycle's a year. Oops. Don't want that. Want that. Now here's a butterfly, one of my favorite butterflies. It's called Gillette's checker spot. This guy lives at higher elevation. It can take 2 years for its life cycle. It'll overwinter as a tiny little caterpillar. The butterfly comes out at the end of the summer, lays its eggs, little tiny caterpillars hatch out, and they spend the winter as a little tiny caterpillar under the snow. Spring comes, the caterpillar wakes up, feeds, grows, becomes a mature caterpillar by the end of the summer, goes under the rocks, whatever, spends the winter as a mature caterpillar. The next spring it comes out, it makes its pupa, the adult hatches, lays its eggs. So it goes through this cycle, but it takes 2 years for the cycle. The guy in the middle is called a rock crawler. They live in really cold places. I'm still trying to find one in McCall. I'm sure they're around here. I haven't found one yet. But they live in cold places. They come out in the winter. That's when they're active. They shed their skin 6 or 7 times when they're going through their life cycle. takes them a year each time they shed their skin. So, but from egg to adult is usually like from 7 to 9 years. And the guy on the right, the cicada, everybody's heard about the cicadas. Can spend like 13 to 17 years underground as a nymph. And then they come out as adults and lay their eggs. And then the egg hatches, it's a nymph, and it's under the ground, sucking on plant roots for 13 to 17 years, depending on what species it is. So we went everywhere from aphids that have 9 generations in a year to cicadas that have 1 generation every 17 years. So that's why when people ask me how long does an insect live, I say, it depends. Said immigration and emigration is something that it's interesting to consider when we're talking about insect ecology. Insects don't always stay in one place. Sometimes they do. Sometimes they're rooted there. Always, depending on what kind of insect it is. There are others like the monarch butterfly. Been in the news a lot lately. Monarch butterfly has its migration pattern. It does. And they spend the winter down in the southern part of the U.S. or Mexico, nesting in trees while it's cold. Then the weather warms up, and the adults take off and start flying north. And they lay their eggs, a few hundred miles away. Lay their eggs, and caterpillars hatch out, and they go through a cycle, and it takes about a month, and new adults emerge from there, and they start flying north. And they lay their eggs, and goes through a cycle, makes new adults, and they fly north, and they get up to about Canada, and turn around, it's the fall, end of the summer, and they start flying back south, and they go back to where their great-grandparents left in the spring, and they'll end up back in that same spot, to roost there for the winter. And then start the migration over again when it warms up in the spring. The monarch is a special case. It's a high profile, real interesting case doing this migration up and back. There are a lot of insects that might spend the winter down south, and then when it warms up they start moving north, and move farther north and move farther north. They have generations. They get all the way up, it's the fall, and they die. And they don't do the return migration. Just the populations that were living down south have stayed there. And there's been a population down there all summer and stays there, and that gives rise to the next generation next spring when it starts moving north. So you've got these migrants that go north, populate places up there, but they don't return back. It's just a population that stays down there in the summer and keeps it going over again. So those are, spectacular things of migration and immigration. But, on a microcosmic scale, it just happens just locally too. You have insects that live in a garden, feeding on squash plants, and then the weather gets good and the squash plants die, and they move across town, find another garden, and populate there. And so that is migration and immigration. And if they move across town and don't find a squash plant, they die. If they move across town and find another one, a new population is there. So it's an interesting aspect of ecology that you have to keep in mind. So, with that, I want to get on to the invasive species thing. I do want to talk just a second about insect identification, because I said it's interesting. It's something you'll probably want to try doing at some point if you're interested in insects. And so how do I identify insects? The typical way is to get some books about insects and flip through the books and look at the pictures and go.
Is there one you would recommend for this area?
If I had to recommend one, I was going to bring it and hold it up, and I forgot. There's a book it's a field guide about insects, and it's by somebody named Kaufman, Kaufman. And I find that to be the best flip-through book to try and identify insects. It's got a lot of good pictures. A lot of the field guides really concentrate on eastern U.S. insects. Kaufman book's got a lot of western stuff in it, so I recommend that. Now, on this paper that I gave you, it's got my name and my email address. If you can't find that book, you can email me and I'll get you the real title. But it's a general field guide by Kaufman. So we flip through books, and that's a good way. It's not the best way, but it's a good way. If there are places that insect reference collections, like we have down at College of Idaho, it's good because you can compare the insect you have with actual ones that someone collected and identified. Because you can look at a picture in a book, and you don't know if that picture is really of an insect that big or that big or that big. So when you're looking in a reference collection, you can see how much variety there is. So that's, sometimes people go, why do people bother collecting insects? You don't need to collect insects. You know, there's so much known about them these days. But having reference collections is good because it helps people that are trying to learn to identify it. It is easier than, or more accurate than just flipping through books and looking for pictures. The last thing is, a lot of insect books have keys. I don't know if anybody's ever worked with dichotomous keys for identifying things. You probably have with plants.
Yeah.
Dichotomous keys are great in the sense that someone's taken a big amount of knowledge and boiled it down so that in theory you can walk your way through and get to the right place. You know, it's like a choose your own adventure thing. You go to the first thing and it says, you know, for a choose your own adventure thing, it says, you know, you walk into the cave or you walk past the cave. And you decide which way you're going to go in the cave. And you see a dragon or you see a werewolf and you decide which way. So dichotomous keys for insects work the same way, except they say the insect has 4 wings or it has 2 wings. You look at it, okay, it's got 4 wings, so I go here. Okay, the front wings are like a shell, or they're not. You know, so yeah, it's like a shell, so you go here, and eventually end up with beetles. But I always have to keep in mind that the people that built these keys are people that know what they're talking about. They know it, they've got this stuff here, and they decided, you know, it's got 2 wings or it's got 4 wings. Okay, it's got 2 wings, it's going to be a fly. It's got 4 wings, it's going to be other things. But you can look at a fly and go, well, you know, it's got 2 big wings that it flies with, and it's got 2 little wings in the back. So you go to the 4-wing place. So then you end up with
in the wrong place.
In the wrong place. So that happens more often than we wish it happened. But overall, keys are interesting and a good thing to try. But be aware that it's never going to be as easy as they make it sound.
They're usually pretty difficult.
I mean, I had, for one example here, I had a key and it's got, does it have a backbone or does it not have a backbone? And they've got pictures of the things up there you're supposed to be keying out, and one of them's a turtle. I mean, we know a turtle has vertebrate and has a backbone because we know that a turtle's a vertebrate, because we know that. But if you were just from Mars and you picked up a turtle and you looked at it, does this thing have a backbone? But, you know, to get through the key, you better say, yes, it does have a backbone. Fun things of entomology. So, like I said, I got more stuff in here than I should have probably, so I'm going to have to figure out how to cut it down a little bit for the other master naturalists, because I really do want to give my invasive species talk to make this an official thing that the department's paying for.
We'll get into some plant dichotomous keys, and we just had a really simple tree dichotomous key for Idaho. That's, if you're talking just about the native species in the mountains, it's a very simple.
And I've tried to, you know, I do insects, and I've tried to key out plants, and I get lost and come up. You know, we got a sunflower, and it comes up in a poppy, and it's, I think everything that's got keys, they've got their pitfalls.
Yeah.
Constant flipping through books and looking at pictures. And then
Or at
some-
least you could get to the part of the book, you can get to a family or something, so you're just looking at,
Mhm.
having to look at that family and not having to look at
Mhm.
the whole broad spectrum.
Right. So I'm going to switch gear. It's kind of switching gears, but it's not. It's just, remember I said for insect ecology and biology, you could spend hours and hours and hours talking about all the topics. This is just part of insect ecology. And I'm going to, I've talked to you about insects in general, and I'm going to talk to you about a certain subset of insects. The insect is a subset that's my bread and butter, pays my bills. Invasive insect pests. I'm going to talk about invasive insect pests, what they are, what the term means. I'm going to talk to you about what is being done about invasive insect pests by various groups, especially the Idaho State Department of Agriculture. And then I'm going to show you some of the invasive insect pests that we're concerned about on a day-to-day basis. I'll just start off this talk with, okay, you guys out there, are insects good or are insects bad? Just to break the ice. And we've talked here for about 2 hours. What's that?
Oh.
I'm glad you got that. I'd be real nervous if I got an audience that was, they're only good, they're only bad. Everyone comes up with this. I mean, clearly we've got good insects like praying mantises and ladybugs. We've got bad insects like Mormon crickets. But if a praying mantis pinches you, it's not so good. Or honeybees, honeybees, they're great. We get honey from them. They pollinate our plants. They're good. They're our friends. We love them. But tell that to the person who just got stung by a honeybee and is in the hospital in anaphylactic shock or dies from it. They might not be so keen on them. Honeybees are good. And Mormon crickets. You want to talk to people, I hate those things that are all over there. Roads all slick with them and they're chewing all the plants up. But the sage grouse is really good this year because they had a lot of food to feed on. And the trout, down here, they were really big trout. So everything is one or the other. But I'm concerned with insects that we generally think of as pests. Pests are insects that we're competing with, that we want something, they want something, and we don't like it that they want it. So we're at odds here. And especially, the pests that I'm concerned with are invasive pests. And invasive pests or invasive organisms are things that generally aren't found here, but somehow they got displaced and moved here, and they looked around and said, this is great. I like the weather. There's all kinds of food here that I like. All my natural enemies that were kicking my butt back where I was at home, they're not here. The diseases I was worried about, they're not here. I'm going to have a grand old time. And then they do. And those kind of organisms that are invasive, they can get established and they generally tend to thrive in the new area that they're put, that they never were before. And when they do that, when we talk about ecology, we talk about the niches, how all the different organisms fit into their niche and have their place in the niche. There's not a whole lot of ecosystems that have empty niches. The niches are pretty much filled. So when the new invasive comes in and takes over and thrives, it's going to be at the expense of somebody else who was there and is getting pushed out. Classic examples of invasive pests are, you may have heard of these, Japanese beetle, gypsy moth. When I first started going to school and learning about entomology, I learned about these pests. I heard about the gypsy moth and Japanese beetle, how they weren't found in the U.S. at one time, and they came into the U.S. and they became big pests in the US. And I am embarrassed to say that I thought this is kind of a special case, you know, a special thing that we truck out and talk about these invasive things that got into the US. It wasn't until recently in my life that I realized that they're not so special. So here's the gypsy moth. It came in to the Northeast 100 years ago. Nobody did anything about it at the time, and it spread out. So everywhere that's purple or yellow or brown, gypsy moth has gotten there over the last 100 years. Where it's purple, it's really deeply established. Japanese beetle, same thing, came into New Jersey, spread out, and on the East Coast there are billions and billions and billions of Japanese beetles. Not so much in the West, but they're spotty. But like I said, I thought this was a special case that happened once in a while. But when I got this job, I learned that it's not so special. It's happening all the time. Things are coming into the U.S. that weren't here, getting established here, causing problems for us. Now here's just a short list of some of the most recent things that have come in, gotten established, and some of the dates on when they first were found in the U.S. You see down there, light brown apple moth, 2007, spotted winged crusophila, 2008, elm seed bug, 2009. And this September I was at a gypsy moth meeting out east, and some people from Pennsylvania went, "Oh, we got a new one. Never found it in the U.S. before, but we just found it in Pennsylvania." It's called the spotted lanternfly. It's native to China, India, Japan, and Vietnam. It's always been in those places. About 7 years ago, it showed up in Korea and just went crazy in Korea. And now, this past September, they found it in Pennsylvania for the first time. And you think, well, that's out in Pennsylvania. We don't have to worry about that. That's thousands of miles away. But Pennsylvania's a lot closer than Korea or India or China, and it made it from those places to Pennsylvania. So look at what it feeds on: grape, apple, pine, stone fruits, tree of heaven. Do we have any of those in Idaho? Do we have all those in Idaho? Yeah. So here's a new invasive pest that the U.S. is concerned about, and we'll be watching for it. Hopefully they'll get it eradicated in Pennsylvania, but we'll keep watching just in case. So these invasive pests that I'm talking about, I'm saying the U.S. has got these things that are coming in all the time and getting established. These are invasive pests we worry about. But that's often the case, but invasive pests also can be something that was found in a different part of the U.S. and then got moved and got established in a place it wasn't before. Some pests in Florida that lived there and were doing okay there, accidentally getting transported to California and then go crazy in California. And we've got a new pest on the West Coast that we didn't have before. We've got invasives like that. And then the bottom thing said sometimes they can move naturally, but also they're often moved by man, accidentally or on purpose. You know, as the world gets smaller, with all our globalization and all our travel from country to country, it gets a lot easier for those things to get moved around. They're small, they can climb in places, and it doesn't take long to get from China to the U.S. 100 years ago, it took, what, months by boat to get from China to the U.S., and now you can do it in, what, a day or less? And the insects can survive in your luggage a day, no problem. For these invasive insects, that list I showed you, they're coming in and getting established. California gets about 6 new invasive species established every year in California. Florida and Hawaii get about 15 new invasive species established every year. Now those are really the special cases for the U.S. because they're warm tropical areas with lots of agriculture, and they have a lot of intercontinental trade going on there, ship ports and things like that. So they're hit hard by this. Idaho, we get less, but we get them. Now, it's interesting, if you stop and think and look at the big picture, you could go, well, animals getting moved around and getting established, that is a natural thing. It's not like the earth evolved and everything evolved right where it is. Things have always been moving, and that's true. But look here, Hawaii gets 15 new invasives every year. Well, scientists sat down and figured out how old is Hawaii, about how many species were there when man first landed on the island. So you can figure out how many new species they got every year back then before man. And they came up with a calculation that before man set foot on Hawaii, it used to get one new invasive species every 175,000 years. That was the natural rate of spread in the world. And now they get 15 new ones every year. So that's why I say a lot of this has happened with the help of man. So what happens when a new invasive species comes in and gets established? As I said before, it competes with all the native organisms for the resources, whether it be plants that they're feeding on or animals that they're feeding on or anything. Competition happens. And by definition, an invasive species is something that often wins the competition. You know, I imagine we get new organisms getting introduced all the time, and a lot of them don't make it, and you never hear about them, and they're gone. But the ones that are tough enough to make it, they're usually really tough, and they often kick the butts of some of the native species, and they compete with the natives, and they knock down the numbers of the natives with feeding on the natives' food. Also, when these invasives come in, they alter the habitat, not just by what they're feeding on, but an invasive species like gypsy moth will get in, it'll attack the trees in the forest, it'll eat the oak trees in the forest, so it'll compete with all the other things that were feeding on oak leaves to their detriment. But also the gypsy moths strip the leaves out of the forest, and suddenly the forest has a lot more sunlight than it used to have. It's hotter, it's drier, and then all these other things that weren't feeding on oak leaves are caught in the collateral damage from this extra sunlight and heat and stuff. So that happens. And then of course, economic problems, and those are probably the worst things for us. We've got invasive species, we hate them to hit our pocketbook, and that's what happens. Say somebody's got an apple orchard and they've been selling apples and making a living for their whole life and think life is good, and then you get a pest in here that suddenly attacks the apples and damages 90% of their crop. First of all, they're losing 90% of their income. That's bad. Then they have to figure out what to do. You know, if we're going to try to keep this business, we're going to have to start spraying for these insects. That costs money. We're going to have to start surveying to find out where they are and make sure we're spraying the right places at the right time. That costs money. So these invasives getting established, a lot of economic problems usually involved. So who cares about this for us? Well, we've got a number of organizations that in the last several decades, invasive insect control has become a big priority. We've got government agencies like USDA and ISDA that a lot of our time and money is spent looking for invasives and trying to deal with them. A lot of conservation groups are worried about invasives. Research organizations like U of I and other universities are involved trying to understand invasives, find invasives, figure out how to deal with invasives. So there's a lot of group organizations working on combating invasive species and doing it in two ways. One, the reactive mode. Oh yeah, spotted lanternfly showed up in Pennsylvania. We got to figure out what to do about it. That's the reactive mode. And then my job is a lot of it deals in the proactive mode, trying to find them as fast as we can. You know, we're worried about certain ones. They've gotten to other parts of the country, or we know this pest, this insect's found in China, and if it ever got over here, feeds on potatoes, if it ever got over here, it'd be a bad problem. So we're gonna spend some money and some time each summer to go out and scout and see if they're here, so that if they are, we'll find them as soon as we can and try and nip it in the bud. So that's the proactive approach that we're trying to take. So a lot of my job is this. We're out watching for them. We're surveying for them, monitoring for them. Every year I get lists from USDA of these are the high-profile pests we're worried about getting into the U.S. And I look and go, well, if it's something that feeds on orange orchards, it's probably not going to be a big problem in Idaho. We're not going to worry about it now. Something that feeds on potatoes, grapes, wheat, this could be a problem for us. So we send off a request for grant money to do surveys to watch for them. So we pick certain pests every year to survey for them. That's part of our deal. Another part of my job is providing information so that people will know about invasives we're looking for and kind of help us out so that you guys can watch for them. I've got brochures up here about some of the invasive insects we're watching for. When you get ready to leave, if you haven't picked up these brochures at the visitor center, feel free to take any that you want. I'll leave the rest here. You can pick them up later if you have classes in there. But we're put together information to get out to the public so that they can help us. Also, so that they'll work with us. If we find an invasive insect and we need to deal with it, we need the public's help to help us deal with it. Because it's going to be usually something that's attacking their neighborhood. We need to treat for it. We need your help to let us treat, not give us, oh, I haven't seen any, so I don't want, it's not a problem for me, so whatever.
Yeah, or you see somebody saying, oh, that new one, that spotted lanternfly, oh, that's a pretty bug, we
Yeah.
can keep that.
Yeah. So we need the public educated to help us, and that's part of my job is to educate the public, giving talks like this, getting brochures out like that. And then the ideal job for me would be put out all these traps, run them all summer, write down 0, 0, 0, 0, 0, or at the end of the year. None of them are here. Another great year. Would be the ideal job for me, but every once in a while we find something. And then we have to figure out how to deal with it. When I got this job, they told me your job will be putting out these traps, surveying for insects, writing reports, blah, blah, blah. I said, oh, okay, cool. And then I said, I'll take the job. Okay, you're hired. Oh yeah, by the way, last year we found Japanese beetle, and it's all over the place, and it's a big problem, and your job's to eradicate it. Oh, you didn't tell me that. But that's part of my job, responding if we do find out they're here. Your job, I say, is why do they think it's worth paying me to talk to you about this? Because we need to have your help. Because I can only put out so many traps. I can hire some people to go out and look in wheat fields and corn fields for these pests, but our number of eyes are limited. The more people we have looking for stuff, looking at the pamphlets, and oh yeah, okay, I'll see if I can find this, that'll help us. And then if you can work with us if we do find it, that'll help us. If you think you found an invasive insect that you've heard about on the news or seen one of our pamphlets, contact us. Most of the time it's a false alarm, but we're not mad. We're glad to spend our time looking and go, no, that's not bad. But thanks for keeping us in mind. Every once in a while somebody turns up something, so it's good. If you think you've seen something, if you can get us the specimen or get us a good photo of it, that helps immeasurably, rather than, I think I've got Japanese beetles in my yard, I see these bugs all over the place. And, okay. Can you send me a digital photo? Yeah, okay. And if they do, I can really tell a lot more from that than just a visual description. So a few of the insects that we're concerned about, like I said, spotted lanternfly, general public probably not yet. We'll keep our eye on what's happening in Pennsylvania. But for me, ready to start putting together a pamphlet about it, just in case. But some of the things that